saw the title of this talk, a DevSecOps approach to network security, to zero trust network security. Wondered how many buzzwords I could get in the title. Well, the original title was a DevSecOps approach to zero trust network security for serverless machine learning in Kubernetes, but they made me cut it down a bit. But still a lot of buzzwords there, and we're going to unpack those today. So first of all, just by way of introduction, I'm Andy Randall. I'm one of the co-founders of Tigera. We're a company that's introducing these concepts of zero trust network security into containers, into cloud-native applications. And you may know us as the company behind open source project Calico. I know a lot of folks here I've been talking to are using that. But we do a lot broader solutions as well. And I'll talk about some of the problems that we're solving and some of the directions that we're seeing the industry going in. So first of all, just to kind of situate where we're starting from, where I think a lot of folks have embraced the concept of DevOps, right? And this is probably familiar to most of you. The concept of DevOps is really all about agility and speed, integrating the processes of software development with the teams that are actually operating and deploying applications together with QA and creating kind of faster deployment pipelines. And so this is a pretty well-established concept, and I think it's been proven quite successful and is driving agile teams. There's kind of one problem with this definition, both in terms of the definition and how this is being implemented in practice, though, and it's captured quite nicely, I think, in this slide. So these great DevOps teams, they're moving as fast as they can, and who's caught at the back end shoveling whatever they leave behind? The security team is kind of an afterthought. How do we secure these applications, particularly when they're moving so fast? If you're going to increase your speed of deployment, by definition, you're you're putting a lot more demands on your security team, and this has created tensions, and we've seen this. So this is really where the concept of DevSecOps comes from. So let's integrate, add security into that, the three-way teams, and make this now a four-way conversation that's happening in enterprises who are trying to be agile. And I like this definition here, and I think the key thing here is it's not just about adding the security team into a process, but it's actually changing how we think about security. It's if you like, it's moving security left in the process of deployment. So rather than saying, let's build the application, work out how we're going to deploy it, and then come and invite the security guys to bolt on some security afterwards, everyone from the initial architect through to the developer, through to the operations teams, everyone in the pipeline is responsible for designing in security from the start and building architectures that are secure. So that's the goal. And the reason why this is important is because when you start to think about the implications of moving to containers, moving to these agile environments, there's a couple of things happening. One is that the applications themselves are getting broken down into smaller pieces, much more dynamic. So there's some calculations, maybe 2 or 3 orders of magnitude greater churn rate of microservices versus traditional VMs. So we're talking about 300, 400, 500 times the speed of change. So that's one aspect. So the applications are more dynamic. The other is that the threats are increasing. I was actually at a security conference last week in New York, hosted by Red Hat, and there was a chart of the capabilities of the attackers, and it's growing much faster than the rate of growth of the security teams, right? So the number of threats, and we're seeing this. You see this in the headlines, but day to day, anyone here who's operating, any kind of modern infrastructure has to be aware that there are attacks all the time. So people are trying to get in all the time. So what's our approach to this? So traditionally, we approach this by saying, we'll just put a firewall at the edge of our deployment, right? Stop the bad guys getting in. This is great, right? And if you stop all traffic getting into your cluster, I think you're probably going to have a pretty secure cluster. The problem is you can't stop all traffic coming into your cluster, because then you would have no service that you'd ever be delivering, right? So we have to let something in, right? And the question is, as soon as you let something in, what have you now exposed? And because applications are getting much larger footprints, getting much more complex internally, and you're going to be using a whole load of libraries that are probably open source, you're pulling in, you don't know what those vulnerabilities are, you can bet the attackers are finding out pretty quickly what the vulnerabilities are. And so the chances are that even with a perimeter firewall, you're going to be allowing some kind of compromise to get into your architecture. And once they've got there, because everything inside the cluster in this model is open, lateral movement to other pods, to other nodes within the cluster becomes child's play. So that's the risk, right? So what we have to do here, and the Kubernetes community has defined an API within Kubernetes that for network policy, and that allows you to bring that perimeter firewall concept and apply it to individual pods within the cluster. And this is great. This allows you to kind of do a micro firewall around each pod. But we've also got the challenge that we don't just have to protect the pods from external threats. We also have to account for the fact that pods could themselves have compromised workloads in. So not only are we going to provide ingress rules, we actually, Kubernetes community has recently added the ability to have egress rules as well to constrain what outbound traffic pods are allowed to have. So this is kind of best practice today for network security on pods, is to be defining fine-grained ingress and egress rules on your Kubernetes workloads. So that's all great. Now, if an attacker comes in, he's going to be constrained within that pod. The next question, though, is in many environments now you're still relying, even where you have this kind of protection on your workloads, you're still relying on a concept of trust in the network. And that may be okay if you control that network, but increasingly people are deploying in clouds where they don't actually control that underlying network. The network is still an attack vector. So one of the things that that I really like about the Istio project is it allows you to easily define TLS security at the network layer between your application components. So encrypting traffic between your pods, as well as firewall protecting each of the pods. This is really starting to get towards a more complete story for zero trust at a network level, and really is what I would say is best practice today. And the question, though, is how do you implement this? How do we get to that model? Because I think if you look at some of the things that are written about zero trust network security, it seems to have a lot of moving parts. How are you going to manage certificates? How are you going to implement these firewall rules? How are you going to know how to operate and manage this? And there's, I would say, most of the people who've really implemented this today have built it themselves from the ground up with some fairly high-end engineering resource. Folks like Google have done this, but probably out of reach for your average development team today, given the resources and the constraints that you're playing with. So this is where Kubernetes network policy comes in. That's one of the building blocks that allows you to build around around each of the pods. Istio allows you to do encryption between applications at the service layer, and what we'd like to do is to be able to put these together. And that's something that we've been working on in our open source project, Calico. So we have something we call application layer policy. This is currently in a preview state, or a proof of concept, but this will be generally available in our next release of the product. And this allows you to combine Kubernetes network policy and Istio layer policies in a single policy definition, a single API. So you can actually, with with just the same interface that you used to for defining network policies, also get an Istio enforced policy as well. So that's great. And if you actually add this up, what you get when you put these things together is what's being called a zero trust network. And if you're interested in the topic, I'd recommend you read this this manifesto, if you like, this book on the topic by some folks that really pioneered it. And they define this. They define a zero trust network as follows: the network you're assuming to be hostile. The network itself is untrusted. So you see how we protect against that with encryption. External and internal threats exist all the time. So again, don't just assume that perimeter security, which is protecting against external threats, is going to protect your deployment. Network locality. So typically we've said, okay, if you're on the same network or you VPN'd in, you're effectively in the same network, that buys me trust. That's not really where trust comes from anymore. You've got to authenticate and authorize every device, user, and workflow. And another key thing here is policies being dynamic, so being applied as the environment changes, as new workloads come in, as new policies are defined. That has to be completely automatic in terms of how they're enforced. And the second aspect there is calculated from as many sources of data as possible. So in the same way that no bank today provides login access to your account via just a username and password, right? They've all implemented some kind of second factor authentication, in some cases even 3 or 4 different questions or different things that they're going to ask before you get into the account. We should be thinking about protecting our workloads in the same way. So check the IP address, check the network it's on, but also check its certificate, and manage multiple ways to validate that the person you're talking to is the person you think you're talking to. So this is kind of how we get to the ultimate goal. But then the question comes, so that's a technology solution. Then the problem that we see, and this is kind of the second half of this, is the organizational side of the problem, right? Because I've given you the ability to define network policies, but whose job is it in this DevSecOps world where you've got dev teams and you've got security teams now getting involved and the operations team? And maybe you're in a large organization where there isn't just one security team, but your particular line of business has a security team. There's a global security team as well. There are compliance teams, right? They all have their own view of the world that they want to impose. And how are you going to integrate and combine all those different views? And that's one of the problems that we see in the real world with these systems, and often I think hasn't been seen by some of the pioneers, because if you look at a model like Google, where they have the SRE who's kind of responsible for the whole deployment, they tend not to have the same kind of multiple organizational teams all trying to kind of put their fingers in the same pie. So whose job is it to define the network security? Well, let's go back to the definition of DevSecOps, right? And there's actually a nice thing I've highlighted in here. So initially I focused on the concept of it being everyone is responsible for security. But here's the second part of that, right? We're distributing the security decisions among these different teams, because you want the person to define their aspect of the security model who best understands the things that they're working on. And so this is a really crucial concept of DevSecOps that I think is often dropped when people talk about it as a kind of buzzword. So let's think about, what does this actually mean in the world of a typical microservices deployment, right? Some of you may be familiar with these roles. They're out of the standard Istio example, the book info application. And this is a simple architecture, but you can see I've got an application where I have a front-end product page, which calls back to the reviews service, which comes back to ratings, and the product page also goes to details. And these are the only connections that we want to allow. So so the application developer, or the person developing these services, can define for each service what are the connectivity requirements for that specific piece of the application. They're the ones that have that best view. But in this picture, you'll see we've got something else going on as well, because we've got this application running in the EU, we've got this application running in the US, and maybe these reviews contain information that's considered, personally identifiable information, and therefore GDPR comes in, and I've got a compliance team that says, that's fine, you can store that review information in the EU, but you need to make sure that there's no way that the US version of the application is going to access the EU data. So they say, we need to define policies to completely separate those out. And you see, that's the end result we're trying to get here. Now, in the old world, we'd have had a network security guy who owned the firewall, who would be responsible for some huge, 40,000 line configuration file with all of the firewall rules in. And these different teams would have gone to him and say, I need these rules enforcing, and he'd have worked out what does that mean in terms of my old firewall rules. In the new world, if you think about the level of complexity that we're introducing with microservices, that's no longer tenable. You can't just say this IP range is in Europe and we'll let anything happen within that. What you do want to happen is have different policies being defined by these different teams that can actually be combined in a sensible way. So we're going to say, my developer is going to, maybe these are 3 different developers for the different microservices, but the developers can come up with the topology of the application itself. And they don't care. The developer shouldn't care about that application requirements for GDPR being deployed in EU versus US. That's someone else's problem. So someone else will say, I'm going to let things within the EU only talk to things within the EU. I'll let things within the US only talk to things within the US. And you want these to be combined in some way. And so when you start thinking about this problem, you actually realize it's more complex than this, because you're going to have all sorts of different layers of policies. And when we've been working with large enterprises with multiple teams, what we're seeing is that there is typically a hierarchy of these things. And you'll have some global security rules, the thou shall never breach this rule kind of thing, which are defined at the very top level. And then they'll go through various levels of hierarchy, and at the bottom level of that is the actual application topology that the developers can give you. And so you end up with something that looks like this, where you'll have a top-level infosec tier, and that's where you'll have things like, there are known bad actors, right? This external IP we just always want to block. Maybe that's where you also say, I must allow this compliance logging, right? Because I don't want to allow the developer to turn off, to create some policy for their application that turns off the logging that I must have on each pod. And then you'll say, if so these are things I'll always deny or allow, and if not, then I'll pass down to the next tier. Maybe the platform folks have some policies that they define. Maybe there's a network a network engineering tier where they say things like, if you're going to do DNS queries, so port 53 only restrict that to internal DNS servers, for example. And then it'll go all the way down to the application tier where you're going to define your application-specific policies. So I really like this model. I think this gets it right, because what it allows you to do, in the same way that you broke up your application into microservices, you've now broken up your security definition into micro-policies, and they're going to be combined in this very agile way. So the other aspect of DevSecOps that you have to think about is logging, and that's a key in monitoring, key part of compliance. And ideally, you're going to have that integrated with some of these policies. So, if you have defined the policies of exactly what is meant to be taking place, this is another way of thinking of this is a whitelisting approach, right? So, in effect, everything's denied unless it's allowed by one of these policies. Now I can start to monitor, well, what is happening because that policy is in place, or which of these policies are not being implemented, or or if I have a deny policy, which traffic is hitting that will indicate to me that there's something bad going on in my network. So So this is something that you have to think about as part of this DevSecOps approach. This is where I'll do a quick plug for the product that we build, Tigera CNX, which does basically integrate all of these capabilities into one platform. So it's all out there for you to use kind of out of the box, and you get these kind of capabilities. So you'll see that hierarchy that I looked at. You get that in a nice management pane. You get all the monitoring and logging. So that in a nutshell is what we mean by a DevSecOps approach, and combining that with zero trust security. And at that point, I can take any questions from the crowd, or dig into any more detail that you'd like. Any questions? Yeah. Oh, sorry, we have to throw the cube.
So is there any tool which combines these micro policies so you can just define your application security policy framework and combine it with your deployment? Yeah. So that is what our product Tigera CNX does. So you can achieve some of this with Kubernetes Network Policy API, but there are a few limitations of the standard Network Policy API. So it doesn't, for example, have deny rules, which are pretty key for these hierarchies. And the other key thing is the hierarchical tiering of policies. So if you look here, I have all those the tiers in a hierarchy, and then they pass through down the tiers. So this is Tigera CNX. That's the tool for that. Yeah. Oh, the cube's coming your way. Whoa.
Thanks. I was wondering if you have some advice with regards to logging when it comes to personal or sensitive data. So we always find it very hard to, on the one hand, log all the data, but at the same time making sure that you don't log any personal data, so anonymizing the data. What's your advice or your recommendation maybe on that?
Yeah, so the way we do logging is essentially logging the network connection attempts, or are successful or denied. So traditionally this has been called 5-tuple logging, right? So source IP port, destination IP port, protocol. One of the things that you find in a microservices environment is because IP addresses are ephemeral. If that's all you log, kind of traditional network level logging tools that are just logging headers, you can't go back and reverse engineer which pods, what pod was that IP, an hour ago. So what we do is logging with metadata. So it'll have the pod ID, it'll have labels, it'll have information about the pod's identity, but we're not logging all of the contents of the packet. Now clearly there are tools where you might want to go in and enable that, but we wouldn't recommend doing that by default just because of the volume that you're going to have anyway. Okay. Any other questions? Yeah. Yep.
I think we were having this conversation yesterday, which is, let's say you're a person running a microservice, and then a cluster admin implements a network policy of some sort, and all of a sudden your app stops working. How do you debug that as like a person working on that?
Yeah, no, that's a great question, and so that's where the logging comes in, right? Because we'll log denied packets, and then you'll see this policy is suddenly getting hit. So if I go to the logging screen, right, I'm showing by policy which policies are denying packets, and I'll see a spike because suddenly that policy is now blocking something that didn't used to be. So that's how we do that.
No, just wondering how you do it, because the thing is, using network policies, it's very hard to debug. It's very hard to get an overview. So exactly. What we need is something like overview. And I'm just wondering what you're doing, because is it just the graph how it's made? It's just looking at the IP tables rules and checking the number of drops per rule, per change.
So
Okay.
it's aggregating that across the
Okay,
cluster.
yeah.
So yeah, I mean, we're intercepting where we're enforcing the rule, but that's aggregated, so you see metrics across, for this policy across the whole cluster, what's it actually blocking or allowing. Yep. Any other questions? Okay. Great. Well, hopefully this has been interesting. Kind of maybe got some of you thinking a bit more about security aspects of some of these deployments, and look forward to seeing us all secure our workloads more strongly. Because I can tell you, this is something I can explain this to my mother. She says, "What do you do?" Look, we make these workloads more secure. So when you log onto services, they're less likely to be hacked, and that's something she can understand. Something we all want to achieve. So thank you.